Hello learners, welcome to Komal classes. Here myself Komal and I am going to represent about the classless addressing, the most prominent topic of the computer network. So let's begin with class, and here we go with the classless addressing and with the ISP that are known to be as Internet Service Provider. So in the previous lecture we talk about the classful addressing, and there are advantages in a classful addressing. So let's do the revision of the classful addressing. Basically the classful addressing have the several problems, and it can be not be used for the larger network. Why? Because if we use the larger network, so we have to change the IP address, so in a long term solution, so we have to change the length of the IP addresses also be increased. So that's why we not use for it for the large network. But in a 90s it can be used also. A short term solution is that if we use the IPv4 address, not the IPv6 address, so it is used in a classless addressing. So the internet service provided come into the prominence in this scenario. Basically the ISP. What is the ISP? ISP is an organization that provides internet access for individual and small businesses and mid-sized organization, so that do not want to create internet site to become involved in providing the internet. So for that purpose ISP will be created, and after that in the 1996 they have so many internet authorities will create the new architecture that called as to be the classless addressing for the larger network. And in this type of addressing we have used the variable length blocks. What kind of a variable length block? We have used the large network into a chunks of the small networks, and the variable length block are used to that belong to no classes, and we have to use it for the large organization into a sub pieces of the small organization. So an organization can be granted one block of addresses. So here we go with the definition first. So write down the definition. So first, in the classless addressing, the distribution of network to provide a fair shot of each organization, and large network can be subdivided into a small chunks of the organization. And the ISP is also called as the organization that provides the internet access for individual, small businesses and mid-sized organization, just like a email. Suppose if you working for an organization, so that organization maybe build up their own domain, and further it classified into a different chunks of the subdomain as well, subdepartments as well, just like a dial-up modem, DSL cable and modem to the ISP. So what about the CIDR notation? So let's do further. This is the CIDR notation. The CIDR notation is also known as the classless interdomain routing. So the classless interdomain routing, it's responsible for how to find the prefix length if address is given. Okay. So since the prefix length is not inherent in the address, so we use for the prefix length. Suppose if you are working in a prefix length of n, so it is added to a address separate by the /n. Here in the diagram, the byte dot, this is the decimal dotted notation, the bytes 4 byte of the given cat, that step tends to be a total of 32 bits in the IPv4. So /n, basically n denotes the prefix length. Here this example says the 12.24.76.8/8. The 8 number of n value is 8. Now the third is number of n value is 12, and the last example, the number of n is equal to prefix length is 25. So here the concentrate students, the size of network is inversely proportional to the length of prefix. Just like that, in a classful addressing we use the same phenomenon there, but in a classless address we use the size of network is inversely proportional to the length of the prefix. For example, if a small prefix means the larger network, here the larger network n is equal to 8, so larger network it is, and a large prefix means a smaller network. So this is the smaller network. So we need to emphasize that the idea of classless addressing can be easily applied to the classful address. Okay, so let's do the example first. Now this is the numerical problem in which you have to give in a classless address and the n value is 27, right? And we have to find out the number of address in the network, and second one is then find out the first address and last address of the given network. So first define the number of address in the network. So this is the basically diagram we have to draw in this slide. So first of all, everyone knows that IPv4 contains a 32-bit okay address, and the prefix length is denoted by the slash n. Okay, so here is the n is tends to be a 27 in the given network. Here is the 27. You can watch easily 27 slash n के बाद जो लिखा हुआ है, ठीक है. So यहाँ पे 27 is a your prefix fixed size length. Okay, and now we have used IPv4 total 32 bits. So we have to put on the rest of the remaining bits are 32 minus 27, that is 5. And how we use the number of addresses? 2 की power 32 minus 27, because the number of node to be used in the that slides. So 2 the power 5, that is 32 total address are required to be number of address in the given network. Okay, so now we have to find out the first address. So before you calculate the first address, I hope that you have aware how to denote the binary notation, a decimal notation to binary, binary to decimal. If you have any problem, so write on the comment box. I will definitely provide the solution for that. So here, first of all, we have to convert this address into a binary form. So 82, we have to first convert the 82 into a binary form. So 82, that is just revise all the things. क्या करते हैं, जहाँ से स्टार्ट होता है जितनी भी बिट है हमें 8 बिट लेना है. क्यों? क्योंकि 32 बिट का टोटल IPv4 एड्रेस होता है, तो 8 बिट हर एक में डिवाइड हो जाएंगी. ओके, एंड यहाँ पे हमें क्या करना है, जैसे 0 से स्टार्ट करते हैं तो 2 की पावर से 0 स्टार्ट, क्योंकि एड्रेस हमेशा क्या होता है 2 की पावर में होता है. तो 2 की पावर 0, then 2 की पावर 1, 2 की पावर 2, 2 की पावर 3, 2 की पावर 4, 2 की पावर 5 and 6 and 7. क्यों? 0 से लेके 7 तक there are total 8 numbers. Okay, so 82. Now write down the maximum bit here. तो 82 से कम वाली 2 की मल्टीपल्स में कौन सी बिट आ जाएगी? 2 की पावर 6. Okay, that is 64, right? That is 64. And after that we have to put on the 1 over there, and after that there are 64 plus 16, that is 80, right? That 2 की power 4 becomes the 1, and rest of the bits are remaining 0. And after that how many bits are remaining? There are 2 bits. So 2 की power 1, that is also 2. So add the 80 plus 2, that is 82. So rest of the bit put on the 1 of there, and rest of the bits are remaining 0. Just like that we have to calculate the 170. So for the 170 you take the homework for that and took in the binary form of that all the bits of the 170. So here I am writing directly now. So 170, that is 10 10 10 and 10, right? And now come on the next address 199, that is hold for the 11 000 and 111, and the last bit 167, that is 10100 and 111. So we have to convert all the address into a binary form, and now we have to calculate the first address. So how we calculate the first address? So here write down the first address. It can be calculated as the keeping the first 27 bits and changing rest of the bits to zeros. Now in the last address here, the last address of the 82, that are first 27 bits are to be keeping first, and change rest of the bits are remain 0. Okay, so here we have to use 1 for 2 की power 6, because the maximum value of this 82 in a large network is a 2 की power 6. So that is 64. So rest of the bits are remaining 0. So here the first address is the 64, right? And come on the last address. So last address, it can be used for the last address found with keeping first 27 bits and changing the rest of bits is 1. Okay. So here we calculate the rest of the bits just like a 82. So convert the all the bits of 1 and to the power 6, that is 1, and also 10, that is rest of the bits are putting the 1 value here. Okay, so overall address will be 95. This is your last address of the network. Okay, so thank you so much for friends for being here. Hope you understand well. If you have any comment, any query regarding the lesson, and any query about the topic, so free to do on the comment box. I will definitely solve the problem. And if you like my lesson, so put the like button, subscribe करना मत भूलिएगा, share कर दीजिए अपने friends के साथ में. Thank you so much for being here. Have a nice day, friends. Bye.